What's up, everybody? My name is Muhammad Rafiatala, and today I'm going to explain the topic of key value storage system. Now, you guys might be wondering why I'm outside of Earth. Currently, I'm exploring the space, but then I remember that I have to do my database system presentation video, so here I am. And also, you guys might be asking Rafi, where is your other group member? The answer is I don't need one. Why? Because this kind of topic is really entertaining for me to make. So I do it alone, both writing the document and also making the slides. But anyway, let's just get into it. Now, before I explain what is database like key value storage system, first I want to explain what is the problem with SQL, or what we usually call is traditional database. So why traditional databases fail at a scale? Now, traditional relational database struggle to handle the massive data loads of modern application. Let's take an example of Instagram. When you upload a picture or even the description and also who you want to tag, it stores in the one big container of server, or what you call database. Now, when you want to query it, want to get the data, it might be really slow because there's a lot of users trying to do the same thing, like a million or even 10 million users trying to upload the image. So that's why it has a high cost and it's pretty slow. So that's why SQL relies on vertical scaling, which means you have to buy expensive computers to grow. Meanwhile, modern apps need horizontal scaling, allow us to add thousands of cheap servers seamlessly. Now, if you still don't understand, let's look at the image. Now, we can see that the key value, or what we call is horizontal scaling. It has an infinite of data. Now, this small tiny server is what you call the key. Now, for example, if you put maybe a user tag or like a user ID in Instagram. Now that user ID must have kind of data. For example, the name of the user, the age of the user, and the birth date of the user, and also all the uploads and the descriptions. So that's why it has a low cost and fast, because it has a lot and it's infinite. Now, next is, what is the key value store? Now, the simplest way to store data is a key value store function like a giant distributed hash map or dictionary. If you still don't understand what hash map or dictionary is, hash map or dictionary is pretty common in programming language, especially in like all programming languages. Let's take an example of Python. In Python, we call it dictionary. Now, what is dictionary? Dictionary is where you save a data by its key. For example, my name is Rafi, right? And Rafi has its data. For example, his age, his birthday, where he is, like university, and what his interests. Now, that stores in as a value, and how to access it. Now we access it by key using my name. So that is the simpler way to what the nutshell about key value. So it uses a simple key to value relationship, removing the need for complex table schemas. Now, because it strips away features like complex joins, it achieves incredibly fast access speeds. Now, if you still don't understand, it's okay. We are trying to learn. Let's look at the image beside us. So, relational database, complex, and join. For example, data table 1 and table 2 is join, and it's pretty slow. If there's like a million user trying to query, then there's a probability that the server might crash. Now, there's a faster and scalable way to do it using key value store. It is simple and has no schema at all. Let's look at the hash map or dictionary. Here you have the user and the ID, that is 101. And what's inside that value with that key? Then we access its name and her orders. And what about the session? We can also put a custom key, not only user. For example, session. It has session XYZ, for example, and we can set if it's active or not active. Now, next is the system architecture of key value. Now, how do we scale using consistent hashing? So we use a technique called consistent hashing to distribute data across a ring of servers. Data is automatically mapped to the next available node on the circle. If the server crashes, the system automatically moves its data to the neighbor, ensuring no data is lost. Now, let's look at the image beside us here. Consistent hashing architecture. We have server A, server B, server C, server D. Now, let's say server A stores key 1 and server B stores key 2. Now, what will happen if key 2 and if server B crashes? Now, that's why you have a dotted line here to directly aim to server C. And server C can store key number 3. So that's why even though we store it in server B, we can see that it's automatically moved its data to the neighbor, so to the server C. So there will be no that there will be no data will be lost using this consistent hashing architecture. Now, what is the theorem trade-off? So choosing availability availability over consistency, the CAP theorem states that a distributed system cannot be consistent, available, and partition tolerant all at once. Since networks inevitably fail, we must choose between consistency and availability. Now, that's why key value stores usually choose availability, meaning that the system never goes down, even if the data is slightly delayed. Now, there is the real world implementation. Like for example, uh, I'm going to explain what Redis and DynamoDB first. So Redis is type of database that store the key value storage in RAM or in memory. So Redis run entirely in memory RAM, making it the fastest option for caching and session management. Now, what about Amazon DynamoDB? Now, Amazon DynamoDB is a key value database too, same as Redis, but the difference is that it's built for high availability, ensuring that shopping carts are never lost even during server failures, for example, like here. So Amazon DynamoDB is fundamentally different to Redis. Now, what makes it different? Redis saves the data inside memory. Meanwhile, Amazon DynamoDB saves its data in hard drive or SSD. That's why Redis, since Redis saves in memory, it is ultimately much more faster than DynamoDB. How much faster? Each in DynamoDB, each time you want to do a query or getting the data, it probably in milliseconds. Meanwhile, in Redis, it's in microseconds. Why it's in microsecond? Because it is saved in memory, and it also has a caching. So when a user already get the data, the other user that trying to get the same data with the other user will get that data directly because it saves in caching. So that's why it's much more faster for Redis. Now, what is the conclusion? So the summary and the future outlook is that the key value stores abandon SQL feature joins for raw speeds. If you don't know what join is, join is basically joining table one, the first table, and the second table for SQL. Now they are they are the backbone of traffic high traffic apps. For example, like Twitter, Discord, and even Fortnite. Now, what is the recommendation? Use SQL for finance or reporting. Use key value for real-time user data. So finance reporting, since finance reporting is like personal information and it has probably huge data, so we have to use SQL. Meanwhile, for getting the user data, like for example Instagram, that's the right way to use. That's the right time to use key value stores. So I guess this is it. That's the explanation for me on about the topic of key value storage system. I hope that explained a lot. If you have any question, please leave a like. Leave a comment in the forum. So thank you everyone for listening and goodbye.